Alright, so let's begin with some examples. Circles on the coordinate plane. Let me go ahead and write the equation of the circle on the coordinate plane as I had from before. Equals r squared. I noticed that in my first video I moved the cursor around a lot, so I'm going to try to keep it more still so that it doesn't drive you nuts there. Okay, so let's start with two types of examples in this video, and then I'll save some other ones that have to deal with graphing for the next video. We want to be able to pull information out of this form, this x minus h squared, and then plus y minus k squared, all squared equals r squared. We want to pull some information out. And the information that we can pull out are the center, which is hk, and the radius, which is just r. I said this, I ran through it quickly before, but hk is the H and K are common letters that are used. You'll see when you get to conic sections and further math classes down the road that those are common points or letters for the points that they use that are focal points. And if you can imagine a circle in the center of the circle, that would be a focal point, just like if you went to a wedding or you went to some major banquet, there's usually a focal point, something that's in the middle that stands out. The center is the focal point, you could say, of the circle. So HK is a common set of letters that are used. I didn't arbitrarily pick those, but I used them because mathematicians use those letters for focal points. Let's go ahead and take an example. We'll have 6 of these, and they should not take very long, actually. Let's say I have an equation like this. Okay, it is the quantity x minus 2 squared plus the quantity y minus 7 squared equals 49. I can get the two important pieces of information, the center and the radius, out of this equation. First of all, I take a look at my form. The form is x minus, so when I pull out the center, if there is a negative there, it's already in the form, so I simply pull the number down. So the center will be at 2, comma. This one's also negative, but minus is in the form, so I pull 7 out. All right, this is not something that is uncommon. You've seen this type of thing in Algebra 1, dealing with equations of lines and that kind of thing. You've seen this thing before where you take the opposite sign when you put it in the point slope form, that kind of thing. It's a similar type thing. You see negative 2 or minus 2, but you pull out a positive 2. All right, so the center is 2, 7, and the radius here is, now remember that on the right side of the equation, this represents r squared. So if this is r squared, then to get r, you must take the square root. So r would be the square root of 49, and this so happens to be a perfect square, which is 7. Center at 2, 7, radius at 7. Let's get a second example. The second example, maybe you'll have one that looks like this: x squared plus y squared equals 36. Well, this may not quite look like it's in the form, but let's think about it. It is. You have the quantity x, and then there's nothing there, it's just squared. Well, the only possibility there for h, in order for this to simplify to just x, is if h were the number 0. Similarly, if k were the number 0, so our center is at 0, 0. Because this is the same thing as like having, I'll write it small under here, x minus 0 squared, plus, and then small under here, y minus 0 squared, equals, oops, I don't mean equals, let's erase that. All right, it will equal 36, but now I want to find the radius, and I know the radius to be the square root of the right side. So the radius is 6. All right, center at 0, 0, the radius equaling 6. Third example. Let's say we have an equation that is the quantity x plus 3 squared, and then plus y minus 11 squared will equal 12. All right, you may see why I chose this example. Notice that I no longer have two negatives inside of those quantities that are being squared. Here, for the center, if it's plus 3, then it's going to be the opposite sign because minus was already a part of the formula or part of the equation, the standard form of the equation. So if you can imagine, this plus here is the same thing as if we had, let's erase the plus. If the form has minus in it, then this would make this negative. Minus a negative would be the plus that we just saw. So this center must be at negative 3, comma, and then we treat this the same way. 11, negative 3, comma, 11. Our radius would then be the square root of 12. Oh, you know why I picked this? Because we'll need to simplify it. All right, 4 and 3 are factors, and then 2 and 2, there's a double. It must come out. 2 radical, we have left a 3 underneath. So the center is at negative 3, 11, and the radius is 2, a distance of 2 radical 3. Okay, let's go ahead and clear this and work the other way around. I'm running out of time here. I want to stay within 10 minutes for these videos. Let's go ahead and start again, this time with the second type of example where we're given the center and the radius and we have to write the standard form of the equation of the circle. So quickly I will write it up here just in case you forgot, but how could you forget? This is your favorite equation. There it is. Okay. X minus h squared plus y minus k squared equals r squared. Let's see, first example. I guess it's the fourth example. Let me call it example 4. Okay, fourth example. Let's say we're given a center and it's at 0, 0, and the radius is 7. Okay, we've seen something like this before. Remember when the center is at 0, 0, when we substitute it in, x minus, well, this is h, 0 squared plus y minus, this is k, h, k. I put 0 in, and squared will equal 7r squared, and that one's more obvious because they tell you that r is 7. X minus 0, well, x plus or minus 0 doesn't matter, is always going to remain x. So I leave it and just square it. Plus y squared will equal 49. I have the equation of my circle given the center and radius. Let's do example 5. Let's say the center we're at negative 5, 4, and the radius is equal to 1/2. All right, let's go back to our form. So it's x minus h is negative 5. We'll square it plus y minus k is 4. We'll square it will equal r. R must also be squared, so 1/2 squared. Let's be careful. Minus a negative, this will become a positive. Just as we said before, it'll be opposite of what you see in the center. So it's negative in the center here, and it's going to be positive inside of the actual equation. Squared plus y minus 4, it will stay squared, and then equals, when I square, remember I'm a square numerator and denominator. 1 squared is just 1 divided by 2 squared, which is 4. And I have my second equation. All right, final example, and then this will be it. Let's say we have a center, and I just wanted to give you some negatives, and a radius that is radical 7. How will this look? So I'm going to skip over this whole process of minus a negative. I think you should catch on to that by now, just as you saw in Algebra 1. So this will become x. This was negative minus negative plus 2 squared plus y minus a negative would be plus 5 squared will equal, now I need r squared in this space right here. If I square r squared will equal radical 7 squared. The square root and the square will do away with one another, their inverse operations, leaving us with just 7. And here is the equation of this circle. All right, next lesson coming up, we're going to put graphs on the coordinate plane and get information from graphs and do some more practice with writing the equations of line given different types of information. See you then.